So I have my cosine and my sine wave. I want to build a surface out of this because I want to have a fluctuating surface. Maybe I want to adjust the period or the frequency of it. And I want to look and build the design off this. I want it to be my building skin. So first is I need to give my panel a height. So again, we went over that the first section of this. So maybe I'm going to move my cosine up in space. So first I have my curve. I don't have to have my original one. And then, again, motion for the move is determined by direction and magnitude. So I need the z direction. And then I need a number slider for the value. So I'm just going to copy one of these. Call that height. Right, so I have my height of my panel. Maybe I want one panel to be longer or shorter. Let's see, that was under time interval, time x. They're all at 12. I'll just make it shorter. There. And then the easiest way to map a surface to those curves is to do a loft. Now, there's many other ways to do a surface, and you can see under the surface menu all the available ways. So basically anything you find under the surface menu here should be under here. You have to just you got to go through the help files and figure out what it's asking you to do. Or you can just email me and if I have time, I'll answer you. Otherwise, there's plenty of help files as well for you. All right, so I just plug in both those transform curves, and then I have my lofted surface. So the question in the room was, if I need to disconnect something, I can hold down Control and move backwards and it disconnects it. Or if I need to plug in multiple values into one component, I hold down the Shift key and I connect in both. Okay. So that handles my loft. So now I need to begin mapping panel surfaces. So now in the sense that we've developed a range of values from our time, make sure I'm recording. I think I'm recording. Yeah. So I can take this same surface and I'm going to map a range or a domain set from this surface. So whatever my U values are, at any point on that surface, I can pull that in real time. So what I do is I can construct a domain from this surface. So it's under the division, actually. If I type in division, I should have the one I want. Actually, it's going to be under domain. So if you type in domain, and you're looking for domain squared. So it's going to be this divide domain squared. So what this will do is it's going to take my lofted surface and say, okay, here's my domain set. Now, how many segments do I want that surface to be divided in? Basically, it's the same as we did before by adjusting the iso curve density. So if you think about this, if I rename that, it's just going to be iso curve density. And whenever you get something from me, if you see this is iso curve density and I type it in and I don't find it, just right click on the component and the help file will always store what that actually is for you. All right, and then I just take a number slider and I tell it how many in the U direction and how many in the V direction. Right, so that should give me a number of segments based on this lofted domain. Now I need to do an iso trim with it. So basically the last part of this is trimming that surface out from those set of points. So I have my surface, which is my lofted surface, and then my domain set was those segments. So then it divides my panel. So what's nice too is this is kind of like doing an extracting the wireframe in Rhino from that isocurve surface and then doing a split command on that same surface. It does it all in one shot for you, basically. And if I bake that, then to see how this is working, what else is running? Huh. Basically, well, I don't know why it's doing that. So what it's doing is it's actually giving me an individual panel on each one of these. Now, last week we talked about lists, right? How I had each one of my gridded cells was acting as a part of a list. So I had to split that out or flatten that list into a series of values. Well, this week we're going to keep the list intact. And we're going to pull specific values from each one of those lists. Now, the list itself, let me decrease the density so we can kind of work on this and visualize this a little better. Right? Each one of these panel segments has 4 vertices. 1, 2, 3, and 4. And then the next panel has another similar list of vertices at 0, 1, 2, and 3. Now, this one I said 1, 2, 3, and 4. This one I said 0, 1, 2, 3. Now, anytime you have a list, in computer programming terms, a list is also called an array. And how we access the first index value of that list or array is by using the value of 0. It's not a 1 value, it's a 0 value. As long as you remember that, you'll be in good shape for lists. So I'll group this together. Now I want to pull out, I have my iso trim surface. The last part is I need to get the actual vertices from that. So I'll go ahead and, to get the vertices and get that list established, I need to analyze each surface individually. So under the surface menu, you can see the analysis tools that are available to you. Anytime I'm deconstructing a mesh or in this case, a B-rep. A B-rep is a poly surface in Grasshopper terms. You're going to get its actual vertice points from that. So I take my surface into my B-rep, and then I have my vertices, my edges, and my faces. So each one is going to give me a separate list of data to work with. Okay. And then I want to pull out my list. So if I look at my panel, if I pull out a panel to look at what the vertices are, right, each time I see another green bar, that's saying that it's operating on another surface in my set. So you can see that each set has a vertice at a specific point, and it has 4 points. So it's doing a 4-point surface from that. And it starts at the index value of 0. So I need to now pull and separate out the list into its individual points so I can begin constructing straight lines to operate on. Because maybe I don't want the surfaces, maybe I want a diagrid from this. Okay, so I'll leave that there so you can look at that, and we'll group that together. Okay, and I'm going to type in list. And then how I retrieve a list item, it's called list item. And I'm going to need 4 of those because I have 4 points in my list. And then it's looking for an index input value. So I can take a simple panel, and I'm going to disconnect by right-clicking, disconnect my original B-rep where I copied it from. And then this one I'm going to put in a 0 value, and I'll do 0 to 3 for each one of these. So I have 0, and that goes for this index item. And then I'm going to copy that down. This one's going to be 1. Copy this down. This one's going to be 2. Copy this one down. This one's going to be 3. And then I'm going to take those vertices, I'm going to plug it into each, by holding down Shift on the keyboard, plug that into each one of my lists. And it should now retrieve each individual point respectively. So if I turn this off, and I look only at my points now, when I look at index value of 0, it's only pulling out one of those. And that's because the other ones are alive and working. So if I look at, let's say I look at index value of 3, it's only pulling the bottom right corner of each one of those panels. And that's why these are not highlighted. So it's separating those out. Now it's duplicating those points as well. So there is a little recursion happening that you may want to address later and may want to be aware of. For this, it doesn't matter. You can just delete duplicates when you bake your geometry. So this one, I'm going to actually do it and label it so I don't get lost and call it bottom right points. And if I look at this list item, this is my top right points. And if I look at this is my bottom left points, maybe I'll just do B left point, PT. So maybe my components aren't so big. And then this one's going to be top left point. I'll do that for this one too. T right PT. T right. Okay. Now the last part is I have my points individualized. I can begin connecting lines to this. So I'm going to need a line. Maybe I want to do verticals and horizontals out of my panel system. We always construct things out of straight lines whenever possible. We always facet surfaces to mimic curved surfaces, just cheaper to do. So I'll type in line, and I can make a line from 2 points. And the first part is I want to do top left to bottom left to bottom right. That should give me vertical lines. And I see that gives me my verticals. Now you'll see that it doesn't give me my end vertical points. And that's because at this panel I'm only connecting the top left and the top right, or I mean the top left and the bottom left. So I also need to connect the top right and the bottom right to connect finish that horizontal line set. So I'll copy that there and connect those together, and then that completes my set. Now again, you'll see that I'm having double up. I have a double up of data, and that's okay. If you wanted to, we could call out all those things, but for this it doesn't matter. I just have my surface pulled out. And those are my horizontals. Now to do my vertical lines, now to do the horizontal lines, it's the same idea. I need to do my bottom left, all my bottoms to all my tops. So this one is actually bottom right. So I'll copy my line set, and we'll do a bottom right point to bottom left point, and that gives me my verticals there. And then remember that I also need to complete this top line, even though I may have it all the way back here, which I'll turn that off now, because I don't need it. I still need to finish that top point, because even though I did it earlier, I'm really just reconstructing this thing out of straight lines. I'm faceting my surface. So then what I need to do is connect then the top left to the top right and finish my horizontals and verticals. Top right, oops. Top right to top left. And that gives that. So that's all my top functions. So horizontals, we'll call those H. call these verticals. Now, if I wanted to make the the fancy thing is Diagrids now. Structurally, they make more sense because it's less material. They're more rigid framing. You connect the diagonal, so it's always more efficient to do things in triangular form versus squares if you can. So if I wanted to make this panel now a Diagrid surface, I need to connect my top left to my bottom right point. So I type in line again, and I can connect my top left point to my bottom right point, and that gives me my Diagrid in one direction. Call it diagonal left. And then if I wanted to go right with it, it's going to be the bottom left point to the top right point. That's going to be diagonal right. So if I don't want, typically if we have the diagonals, we generally don't ever need the verticals and horizontals. So I'll just preview those off, and then I have my Diagrid out of that surface. Go. Group that together. Now what's nice is if I needed to, maybe I had a surface that wasn't, mathematical. I just kind of made a surface. So maybe I'll loft my own here. So I'll do in Rhino, I'll explicitly model a surface. So I'll interpolate. Excuse me. Go to curve, freeform, interpolate points. Turn off ortho. Leave planar on. There. And I move that vertically, and then I loft those two together by hand. Right, I get some kind of goofiness going on, but I can do that same function now. All I need to do is instead of using my original pieces as surfaces all the way up to this point, I can just type in surface and make a container for my surface and set that from Rhino. So now it is my Rhino geometry, it is Grasshopper geometry now. And I can also plug that in by holding down the shift key into my domain for my isocurve. And let's see, it gives me an error. Oh, I need to do one or the other. So I'll copy this down. And hopefully, it says surface is singular, so subsurface is invalid because trimming B domain is singular. Oh, it's still connecting. Ah, that's why. Two different surfaces. There we go. So now I can do that as well with that surface. So really, I don't have to go the math route with this. I can do one or two with it. I need to disconnect the other surface. So disconnect. Hide. So I have one that's mathematically driven, one that's explicitly driven for that. Is there any questions on that? So I've also now a couple other things, and I have to go back, and this is why I'm not going to show you it, but I'm just going to give you the definition to play with, is if I have, I'm going to save this document as Grasshopper 01 now. So I'm going to overwrite what was there. Actually, at the end of class, I'll overwrite what was already there, because this one's probably organized a little better for you. The last part is mapping curves to a surface. So I'm going to go ahead and open my tutorial 02, I believe is the set, hopefully. Actually, it might have been 03. You might get a glimmer of what we're doing next.